So data visualization workshop part 3. This time we're going to cover the visualizing variance and correlation. This is actually a very interesting topic. I'm really passionate about it. Um, and this is the workshop we started, I think like 2 weeks ago or so, starting with the basics. And then last week we talked about the time series data. And then we are also planning for like other topics such as uncertainty. And also when you visualize the data, you always have to do certain amount of the sort of like data wrangling, we call it, but transforming the clean up the data. So we're gonna cover that as well. Okay, so let's get started. Today's agenda, basically, it's really the visualizing variance and association correlation stuff. But I want to set some expectation at the beginning. The two principal questions for exploratory data analysis, or we call it EDA. So what is EDA, or exploratory data analysis, which is an exploratory and iterative process of asking many questions and find answers from data in order to build better hypotheses for explanation and prediction and control. So when you have the data, you ask a lot of questions and then you answers, and then sometimes the answer leads to another questions. But then what you're trying to do is try to reach to start building a hypothesis, right? And then this exploratory data analysis was created by this person, like John Tukey. According to his quote, so far better and approximate answer to the right question, which is often vague, than the exact answer to the wrong question, which can always be made precise. And this happens a lot. That reason, like I brought this up, is like when we talk about exploratory data analysis, or even like data analysis, when you get the data, you start working with different charts. Most of the time, or sometimes, I see that people are working on the wrong questions because they just want to do something with the chart. They just want to visualize and hoping something is going to come out not automatically. But most of the times, you basically like you want to set like what you're actually trying to achieve. And then two principal questions for exploratory data analysis. Number one is how the variation in variables. And the second is how the variables are associated or correlated to one another. And why these two principal questions? Because I think I'm gonna, in the middle of this presentation, I'm gonna talk about what are the association correlation, but these are two key questions. When you do the EDA, you actually really try to answer these things. Of course, when you have the sales data, like what you're trying to answer is not about the variation itself. You are trying to understand the sales, how the sales numbers are made or created. But the generic questions are always these two things. Then the best way is to visualize and using the charts to answer those questions. So I'm going to introduce histogram, density plot, and scatter plot, box plot, Violin plot, stack bar, these charts today. And then in order to do, I'm going to use a sample data, and I'm going to use a human resource data or employee data. Each row is each employee, and it has like a 27 attributes such as age, income, or job role, and so on. Okay, so this one, you can also download this data as well. To do, you go click on this, here's exploratory, and then click on this like a plus menu next to the data frame. There is a data catalog. When you go here, and then you can access you have to be online, but you're basically connected to our server, which is exploratory.io, our website. And we host a bunch of sample data there. So one of them is called HR employee attribution. You can find it if you couldn't find it. Sorry, that was kind of a weird thing to say. Like you can find it by typing something to search. But anyway, so like this, we're going to use this HR employee attrition data today. So what you want to do is click on this import button. And then that basically download the data from the server. And then all you need to do is just click on save button. And then the name, you can name it anything you like. Okay, so now that we have the data, and then I'm gonna just hide the left-hand side. There's like a list of the data frame area. I'm gonna hide it. You see this highlight and correlate these two buttons. These are going to be from version 6.0, which we are planning to release, hoping this week or maybe next week. So don't worry about that. Like if you don't see this menu or buttons in your version of Exploratory or whatever that you have. Okay, so now, so we have like 27 columns and 1,470 rows. That means we have 1,470 people or employee in this data. Okay, and then when I go here, table view, so each row is each employee, and then has, for example, is this person is a female or male, or like what is the monthly income, like how much they're getting paid every month, or for example, like how many years they are with this company, type of information. Okay. Then today, what we want to focus is there's a column called monthly income. And that's what we want to understand. So in this company, like how the people's salary or like income being decided, and then what makes some people getting paid higher than or getting paid lower. Those are the things that we want to understand. Okay, so let's go to the question side. Okay, so how is the variation of monthly income, and what makes it vary? Like why there's a variation, and what are correlated? What are the things that correlated to monthly income, and how they are correlated? These are the questions that like we want to answer throughout this session. Okay, and when we look at the monthly income under the summary view, we can quickly see the minimum value and max value. So this ranging from $1,000 to almost $20,000, and that's a huge variation. Some people making $20,000. This is actually monthly income. That's a lot, and then 1,000. That's very little. So those are the differences. And then when you look at the average mean, which is $6,503, so that's the average, but there's a huge gap. So we want to understand why that's a huge gap. What makes that difference? And then we want to visualize the variance. And that's where so, it's actually the data usually varies. There's always variance. And if that's actually good news, because if there's no variance, imagine like everybody's getting paid exact $6,000, then your data analysis is just stop there. There's nothing to find. But if you see like the huge variance, typically just some elements or attributes that contribute that variance. And that's the sort of like a beginning of the data analysis. So it's a good news that we have the variance, and so we want to find something more in that data. And then typically, here's also the questions for the variance when you look at visualizing the variance. These are the things that like you should have in back of your mind. What are the typical values? So this can be, for example, monthly income is like a 6,000, around that area, like between like 4,600 are the typical income. We don't know. Are there any outliers compared to the general trend in the variance? So are there people like, for example, few people getting paid super high, super rich people, or super poor, super low income, or like what's going on? And how that data is distributed, meaning like what type of the shape of the data when we start visualizing. And are there any patterns you can spot in the variance? Maybe like there's some kind of a weird area where the monthly income range that there are a lot of people, or some other patterns maybe you can find. So these are the things that like we are thinking or like when we're visualizing. And then these are the charts, like histogram, density plot, bar chart are the one that you usually use to understand the variance. Okay. And how to pick which charts to use, that's always the questions. And depends on the data type, really. Then we have two sort of like a big categories of the data type. One is the continuous data, and the other is categorical data. Names kind of like for some people might be new name, new concept, but it's nothing but typical things that you have already been seeing. What do you mean? What do I mean by that? Well, continuous data is really is a numerical. It's like numbers basically, and they're all date and time. And then what the nature of the numerical, today we're going to focus just on numerical. Time and date and time has its own thing going on, which we covered last week or the part 2. Today we want to focus on this numerical and later on categorical. So numerical, the nature of that is a continuous. So like from 0, 10, 20, 30. And also between the 10 and 20, there's a 10, 11, 12. 10, between the 10 and 11, there's a 10.1 and 10.2 and so on. It continues. And also the ordinal relation, and it's sort of like obvious. It's like, 11 is always higher than 10 and such. And then when you want to visualize the variance of numerical variable, typically like you want to use a histogram and a density plot. Okay, let's start with histogram. And a histogram is, it basically like numerical values, but it creates sometimes we call it bins, sometimes we call it buckets, but nonetheless, it splits numerical values into a set of groups or set of bins or set of categories with equal range. And then it shows a size for each bin or each group. So in this case, for example, this is the age as the x-axis. And then from like ranging from 20 years old to 60 years old. And then we just, let's say like make a super simple case, like divide into 10 and to make sure like each width of the range to be equal. So now the question here, how is the variance of monthly income? So like I said, we want to focus on this monthly income. And then there are other 2 questions, but let's start visualize monthly income to understand what's the variance. Okay, so let's start. We're gonna use a histogram. So here's a monthly income. And I'm gonna go to the chart and then select the histogram. I'm gonna just make it screen bigger. And then x-axis, we wanna use this monthly income. What happened here? Oops. Monthly income. Okay. Monthly income. And then now we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 groups or 10 bins. And each group has its own range. So it's like $1,009 to $2,908. Okay, and it looks like, seems like there are a lot of people between this range from the $1,000 to $6,700. And then like this shape of, we call it distribution, but this shape start going down after that point. And it's almost like very less people around this area, between like 14,000 to 16,000. But then after that, it looks like there's sort of like a mountain, right? There's a hill, it's just start going up. That means, for example, 18,000 to 19,000, like a 20,000 range. There are more people than a little bit the next range. So it looks like there are like some chunk of the people here. Okay, so and then like we want to understand even more detail, more granular level, you can adjust the number of the bars or number of these bins. So for example, if I type 50 here, I'm gonna make my mouse pointer to be a little bit bigger so that it's, here we go. Cursor size, okay. I just wanted to make it easier to follow my mouse pointer here. Okay, so now here's number 50, and then like I'm gonna click on apply or click on hit the return key, and then now each bar has now like a sort of like a smaller, narrower or range. So now, for example, this bar is representing like 142 people whose monthly income ranging from $2,148 to $2,528. And then here, we can even make even more granular, let's say like 100. And then the more granular you get, each bin start having like less people because of the narrower range. But nonetheless, like you can start seeing like some of the pattern here. So number one is this range. This is like almost like Empire State Building in New York, but this area looks like there's one sort of like a hill or the mountain, whatever you call it. And then so this range of the people making from $2,000 to maybe like $3,000 range. And the next mountain is here. And then like you see like a couple of other mountains or like this is like a hill or whatever you call it. And these are the good sign because it looks like there might be something that is making this group different from the next mountain and different from the next mountain or something. So the question is, what are the things that making these each mountain or makes it different? Or maybe these are multiple groups might have something different from one another. Okay. And then what you can do is you can start using that, for example, the color. For example, I'm going to use maybe like a gender, like a male and a female. They might be getting different amount. So like I want to investigate that. So like I'm going to assign a gender to the color. And then if you see this like orange is a male and blue is a female, if you see this orange and blue have the different histogram, not much overlapping, then hey, like maybe like there's some kind of gender gap. But in this case, it's hard to see the differences. Not it's kind of hard to notice that. So maybe that's what it is. And then how about like other things? So like in the color, I'm gonna assign something else. So like here's a job role. And the job role is, for example, something like human resources, a manager, or sales executive, and so on. And then you can see some differences among the job roles. For example, when you look at this like a red color, like I see like a red color on the right side, these two mountain areas, but I don't see like much on the red having left side of things. And I see the pink at the left-hand side. It's a very like a lower range. So for example, pink is a research scientist. And also another color is this one, this sales representative. So these people and salary or income are in a very lower range, as opposed to this red manager people in a very high range of the income. So you can start seeing like what is making the monthly income different or go low or high or medium or so on. So that's good. But then here's the one problem. That it's easy, I don't know, easy or is a good word, but nonetheless, we can spot the difference between certain type of the job roles. But the problem is they are like 1, 2, 3, almost like I think it's like 9 job roles, and they are on top of each other. So we can't really see the differences, more like clear differences. For example, like I'm not sure this gray is stopping here or which range and so on. And that's where like you want to change to density plot. So I'm going to change it, the chart type from histogram to density plot. And the density plot is very much like a histogram, except try to draw the smooth line based on the actual values. It's more, maybe I should say it's like estimated values. So to try as smooth as possible, and then therefore, for example, this orange line, like when you look at the orange line, when you see like somehow like there's a monthly income, the minus range, negative range, but that's because if you have the data, actual data in the distribution, like the way like we see in the histogram, then it can be estimated to this curve. It's ignoring if this number has to start from 0 to something. But nonetheless, you can kind of understand the overview, sort of like an overall trend. So that's very useful. And also another thing is that it's always the size, I'm not size is not the right word, the area is always the one. So when you, like focus on just like a orange, red color, which is manager. And also I'm going to bring the sales representative. Sales representative and manager. So there are two completely different shape, but both of them is the size is one, or like area is one. So when you this area under the curve is equal amount. So that means the higher that this curve goes, then it tend to be a skewer, or the range tend to be narrower. And when this mountain is lower, then the range tend to be wider, because always that area, the size of the area is always 1 or 100%. Okay, so I'm going to just bring everything back here. And from here, we can see is the same thing we can tell. Like, for example, manager is a high range, and then this sales rep and also research scientist are the lower range. But this sales representative is really high. That means most likely, like if you're a sales rep, you're making the income between this range, and it's very like strong signal here. And then also, like you can see like a middle range. For example, the sales executive, this like a gray and then purple and then blue, and the healthcare representative and the manufacturing director. These guys are making sort of like a kind of a middle ground. So this chart helps you to get even more understanding or clear understanding of the data distribution, or how the variation of the monthly income in this case. So these two charts go hands in hands. So it's a different, but basically trying to provide a similar information. And it really depends, what you want to understand. There's no, clear rule. So it's basically the same data being visualized in different ways. And then one thing though is a histogram is what we are looking at is actual distribution. So when you have like, for example, one bar, that's actually, it says like 40 people, that's exactly 40 people there. Density plot is it's more like estimated, sort of like a ratio or probability. So like, if, you can guess like maybe like 20% of people in this area, you can say something like that, but it's not exact number. That if you don't see like exact number, you want to use a histogram. You want to see like overview or overall trend, density plot gives you a better idea. Okay. So now, like we were looking at the variation of continuous data, but how about the categorical data? Categorical data meaning it's not continuous. So it's like typically the character data type. So like Texas, California, New York, those are not continuous. There's no Texas 0.1, Texas 0.2 kind of thing. And typically, there's no ordinal relationship as well. It's not like Texas is better than higher than California and that kind of stuff. It's when you look at only the characters. When you have a population which is numerical, then all of a sudden there's a relationship. But if you're looking at just that name of the Texas and California, there's no ordinal relationship. So these are, we call it categorical. Then, if you want to see the variation of the categorical data, typically you use bar chart. This one is very simple, like it's just a bar chart actually. So this typically like what you do, you have been probably doing. So I'm not going to really go into that detail, even the demo. I'm going to just kind of skip through. So when you, let's say like the question is like, what is the variation of the job roles? Well, like you have 9 different job roles, and then looks like a sales executive, research scientist are the top job role in terms of like number of employees. And then you can sort, and then like that make it sort of like easier to see like what other job roles have more people and what other job roles have fewer people. And then you ask questions. So what making difference? So for example, gender plays certain jobs like more male, more female, or maybe no, I think that's it. So in that case, you can use a color and assign a gender, for example, and then you can see like orange and blue, and then you can also click on the side by side. Then you can see, oh, okay, for example, left on the most left bars, like a sales executive, orange is male. So like, wow, there are many more males in sales executives than female. And then when you look at the fourth from the left, which is manufacturing director, the female and the male, pretty much around the same amount of the number of people. So like, okay, so in that job, it's pretty much 50-50 kind of stuff. Also, you can use visualize as a ratio. This one is, I'm going to cover this at the association section later. So I'm going to skip this. Okay, so those are the variations. Like we basically been using histogram, density plot, and bar chart to understand or variance by visualizing it. And from here, like I want to step into the association and correlation arena. So association and correlation, precisely we in this world of statistics, and then we differentiate these two. But depends. Like I mean, I'm not the academia person, so like I'm not gonna go into like super hard on this definition kind of stuff. But nonetheless, relationship with these are the relationships where changes in one variable or one column. I'm gonna start using the word called variable. But it really is a column in this case. The one variable happened together with changes in another variable with a certain rule. So here, association is more like a broader thing. So like any type of relationship between two variables. If one variable and another variable, you see the relationship, that's association. The correlation is a certain type of association. Typically, is a linear relationship in the world of statistics between two variables. And then those two variables, typically the numerical variables. Okay, so the association, for example, let's say like, the country. In this data, we don't have the column country, but I just imagine like let's assume that we have. So like US, UK, Japan, and then people, making a different income. But when you visualize the range or the variation of income for each country, then you see the difference. Then you can say, well, like looks like a country and a monthly income are associated, meaning when the country change, or from US to UK, the monthly income change, in this case, going down. And the correlation is, I say like a typical, a certain type of association. And in this case is like age and monthly income, both of them numerical variables. And then when the age increase and the monthly income increase, when you visualize, and then you can see this sort of like a linear relationship. Doesn't have to go up, but any direction, then we call it a correlation. The correlation is actually a very interesting topic because you can you can quantize the correlation, like how strong the correlation is, how weak the correlation is. Sorry, quantify the correlation. Sorry for my English. Then, so from ranging from -1 to 1. So -1 is the most strong negative correlation. That means, for example, the age increase and the salary income decrease. And then the right-hand side, the strong positive correlation. In that case, we have 1. And there's a way to calculate these numbers, by the way. So I'm not going to go into too much detail on how to calculate that numbers, but in the world of correlations, you can have these numbers calculated based on that data. And then the strong positive correlation is 1. And then when you have 0, that means no correlation. That means these two variables, let's say age and monthly income, doesn't matter. Like it doesn't matter like how old are you are. Like a monthly income gets decided based on completely different rule or something like that. So then you can't even, when you visualize, your eyes can't detect any patterns or any trend or something like that. Okay, so having said that, so why association and correlation, what we are talking about? These are actually the almost like most important thing when you analyze the data in the world of data analysis. And then, so why is that? Well, because like we saw, the numbers usually varies. There's always variance. There never be like only one single value. So usually there's average or mean. It can be the median too, but there's a kind of like a center value. But then typically the number goes up and down, right? Then These things, we call it like uncertainty. For example, monthly income ranging from 1,000 to 20,000. So like uncertainty. We don't know like what, how, if a given person, how much income they're making, we don't know because the range is so big. But if we can find a correlation between monthly income and something else, for example, working years, then all of a sudden we can start being able to answer. Let's say like if your working years is 20 years, then you are most likely going to get paid around $15,000 a month or something like that. So what just happened is if we find a correlation, that means we can reduce the uncertainty. Oops, what happened here? Uncertainty here in this case, the monthly income. We don't know like if it's $100 or $5,000. I think left hand side the number is wrong. I think that should have been $1,000 to $20,000. And we don't know, but once we find a correlation by using the one variable, in this case, working years, then we can better answer how much monthly income will be. Same thing, if we find even like association, like in this category, like US, UK, Japan, if I know you're from, let's say, like Japan, then we can see like probably this is the range like you're making. So we can't eliminate the uncertainty, but we can reduce the uncertainty. So that means if we can find strong correlations or associations, it makes it easier to explain how, in this case, monthly income changes and to predict what monthly income will be. So this explain and predict is the two important things when you analyze the data. And correlation or association. This is actually a tricky thing. And then this can be, it's almost like a cliche. So probably like it's just another thing you hear from somewhere else. Correlation is not equal to causation. So typically like when you find two things that seems to be correlated and you get excited because, well, this is why another thing is happening. But that's a very tricky subject because causation is a special type of correlation. So when you find a correlation, it's actually great because, that reduces uncertainty and then you can, predict or explain why that's happening. But when you explain why that's happening, is which you're getting into the territory of causation. And causation is a tricky subject because the correlation is not equal to correlation, and there are other ways to investigate or test if this is a causation or not. But we're not going to that arena today. We're going to just stop at the correlation. But if you don't have correlation, then you don't have a causation. I mean, of course, it's not always the case, but typically. So nonetheless, like finding a correlation is really the great starting point for like your data analysis. Okay, and then let's start getting the visualizing association and correlation. So how to choose the charts, right? Which charts I should use? Well, again, depending on the combination of data types. So categorical and numerical, or numerical and categorical. So let's start with the categorical and the numerical. Okay. And then to do, we're going to use a Boxplot and Violin plot chart. Okay. So the Boxplot, I want to explain just to make sure like everybody on the same page. So it's really like we've been using histogram and density plot to visualize the variation or the variance. And then you bring that to sort of like a 90 degree. So like now it used to be x-axis, now it's a y-axis. This is showing the range of just, let's say like monthly income. And then like I put like each employee in that range. And then we separate them into 4 groups to make sure that each group will have the same number of the people, or we call it equal size, but it's the same number of the rows, the same number of in this case, of people. And then when we separate into 4, that means each area should have 25% of the people. Okay, so these we call it like a 25 percentile, 50 percentile, 75 percentile, or first quartile, second quartile, and third quartile from the bottom to the top. And then, by the way, this second quartile or the 50 percentile is actually the median. It's basically it's like in the middle. The box plot is really the center part of the box is representing the from first quartile to third quartile. That means, and then the line in the middle is a median. So that means this box itself always should have the 50% of the data, or 50% of the people in this case. And then the bottom and then the top indicates minimum value and the max value. So if you want to see the range, then you can see that this line. If you want to see the sort of 50% of people in the middle, then you can see the box. So this gives you the idea of like how the data is varied in a particular and in a given variable or column. So now let's use a Boxplot, but here are the questions. So first question, how is the variance of monthly income associated with job role? When the job role change, how the monthly income different? We already have some idea, right? So that because sales executive, the manager are getting higher income, but let's use this Boxplot. And also like we want to see like how the gender plays a role. And also like when the gender and the job role play the role together. Okay, so I'm gonna just get into, let's create a new chart and then select the box plot chart. And the x-axis, first let's start with the job role. And then like, we wanna see like we are interested in monthly income. So we assign a monthly income. And then like, we see like a different range, right? So like obviously the manager and the research director, these folks, there's a variance. It's not like one single value for the manager, but even the variance is very different from like, let's say laboratory technicians or even like manufacturing director. I'm gonna sort these box plots so that makes it easier to see. So like manager and research director, those are the top two range. And the next group seems like a human representative, manufacturing director, sales executive. These are the three next, kind of like a middle range. And then the lower range, sales representative, laboratory technician, and then research scientist, these guys seems to be getting less income. And this align with what we saw with the density plot already. So it's not like new information like you're finding, but similar information, but it's just a different way to look at. And then from here, let's say like if I change that to gender, for example, like a female and a male, they're making a different income, and it seems like there seems to be some difference, but it's hard to see. So I'm gonna just bring it back to job role, but in each job role, maybe might be some kind of difference between the female and the male. Let's say like in the manager, maybe male is getting more or female is getting more. Let's find that out. So we can use color and then assign a gender. Now the male is orange and the female is blue in this case. So when you look at the manager, seems like male, the similar range, but for example, you remember this horizontal bar inside the box, that's a median, it's like a center. Even the median is different, like a male is higher than female. And the 50% box is, when you look at that, the male is higher than the female. So seems like the manager role, like male is getting higher income. Same thing, the research director. The research director, the difference is even higher. Difference more noticeable. And when you look at the median, or when you look at the box, which represents 50%, the kind of center people or the values. And when you look at, for example, human resource or research scientist, and maybe some other jobs, like for example, manufacturing director, and Bruce seems like higher. It's almost like the same range, but it's slightly higher. So some jobs female are getting higher, but some jobs of males are getting higher. So those type of things you can start finding. Okay, and then this is a box plot, But there's another chart called Violin plot, which is basically the same. It's very similar. I'm going to take this agenda out to make it easier to see. So this Violin plot is more sort of like advanced version of the box plot. You see the box plot inside, and then there is this kind of curvy thing. This curvy thing is typically, it looks like, for example, this one looks like a violin, so that's why like it's called a Violin plot. But it's showing the density plot line. So this basically combine a density plot and a box plot together. So it has a lot more information. And also, when you look at here, the dotted line, the dotted horizontal line, that is actually the mean or average. So not just median, but you can also see the mean and also the sort of data kind of a distribution or estimated distribution of that data. So for example, let's say like a research scientist, a laboratory technician, seems like the higher the monthly income goes and then like less, much less people and then like kind of a lower range, like sort of like a high peak is like the lower range, even though like the median and then also the 50% box is higher range, but at the peak is actually almost like a 25 percentile area. Okay. And then if you want to see under the property, there is a short data as a point. So this might give you or your coworkers you're sharing with have a better idea of like how the data is distributed. So this dot, that's the actual people, right? So, and then what we are doing by using histogram, density plot, and box plot is try to simplify these data so that we can understand the overall trend. That's all we were doing. And then, but sometimes you want to see like, so how are those people there so that you can show these dots. Then this might give you even better idea as well. Okay, so that's, we are looking at that like a categorical and numerical. Okay, so like x-axis is categorical and then y-axis is numerical in this case. Now, next topic is what if like numerical. For example, there's an age and numerical, and then the monthly income is numerical. How can we visualize? That's where the scatter plot comes in. Okay, and then basically what this is like really the area of the correlation. And then when you see these patterns, you know, for example, the right-hand side, the left-hand side, that, you know, that is basically giving you a strong signal that like, these two variables are highly correlated. So here are the questions. How is the variance of monthly income correlated with the variance of age? And also, how about with total working years? So these two things, let's take a look. And then I'm going to create a new chart and select the scatter plot. There are two versions. One is aggregate, the other one is no aggregate. We're interested in the variation of data, and then we want to find a correlation between these two variables. Therefore, like, we're going to select the no aggregate. If you're interested in with aggregate, let's take a look at the part 1 of this visualization workshop. Okay. So I'm going to select the no aggregation, and x-axis, I want to select the first like age, and the y-axis, the monthly income, so that we can see if the older you get, then you higher the income you get or not. So looks like this such trend. This it's if anything, like almost like from left hand side bottom to the right hand side top. But how strong is that relationship? And you can actually use something called trend line. And when you go there, and you can select this linear regression line. Linear regression is a statistical learning model. We have like online I did an online seminar before. If you're interested in, take a look. But important thing is by drawing this line is basically being drawn so that distance between all the dots, all the data points, and then line to be minimum. So it's kind of like a going in the middle. And then when you bring the mouse over on the line, you can see a set of metrics. One of the things that we are interested in this time is a correlation. It says 0.49, it's about like 0.5. So it has a certain relatively high correlation value. It's not like 1, or it's not like 0.9 or closer to 1. So it's not as strong, like a kind it's not like very strong, but still it's not like 0. So there's certain relationship between these two. Okay, and how about not the age, maybe number of the years you work in this company might matter a lot more than the age. So like we can test that by using this total working years. Okay, so now x-axis total working years, and then like y-axis monthly income. And then let's see, the data itself seems like there's a more correlation than before. But and also this number is saying correlation 0.77. So that's higher than the 0.49. So that means total working years and the monthly income has higher, more correlated, highly correlated compared to between age and monthly income. Okay. So now, one of the things. So when you see this 0.79, so it looks like this company, like the longer you work and then you get paid more. So you remember like we saw, we saw a job role also like has a huge impact or like an influence in terms of like a monthly income. So is this relationship between total working years and monthly income would be the same in any job role? For example, like sales executive, for example, manager or research scientist, if every single job role will have the similar trend or correlation. So let's find out. And so what you can do is here the repeat by, basically create this chart for each job role. So I'm gonna assign a job role to the repeat by. And then now what we are seeing in the scatter plot we saw being created for each job role. So let's say, for example, healthcare representative, and then that's 0.65. So it's less than the overall trend, but still there's such relationship. Human resources, 0.62, research director, 0.63, and so on. Laboratory technician, 0.40. So in a laboratory technician, the data is about from 0 years to 20 years, but there's not much compared to other job roles. That working years doesn't have much impact on the monthly income or and so on. So depends which job role, the relationship between the total working years and monthly income differed. So those are the things that we are basically finding out. Okay, so from here, so we are basically visualizing these relationship. But one thing is so left-hand side is the chart we've been seeing. So if it's numerical, we use scatter plot. However, numerical values always can be converted to categorical values. Like we saw, basically histogram, what histogram is doing is just that. So create a range, right? So from like, let's say 0 to, if this is total working years, starting from 0 year to 40 years, and how about like making it from 0 to 10, 10 to 20, 20 to 30? So create a sort of 5 buckets or four buckets of how many buckets could be. Then each bucket will have the range of the monthly income. And then we can see sort of like simplifying the scatter plot on the left-hand side by using a box plot. So then it might help you to understand more the relationship between these two. So that's what let's try to do. Repeat by, I'm going to remove repeat by to make it simpler first. So now what we're looking at is the total relationship between total working years and the monthly income. And instead of using the scatter plot, I'm going to change to box plot. I'm going to select that. If you like, you can use Violin plot too, but I'm going to use box plot just to simplify. Okay, and it automatically, when I assign the numerical variable to x-axis, automatically categorize it, because box plot by definition x-axis has to be category. So, and how it's categorized is it says category equal width. So like it makes sure that each width or like a range to be the same. In this case, every 8 years or something. And I can change it though. Like now it says 5 when I click on this green button. And then the default is 5 groups. But let's say like I want to make it even like smaller, like 10 groups or something. Then each group is now like 4 years. And then like I can see, okay, the total working years, the longer the working years, and higher the monthly income. And that trend we saw in the scatter plot is there. But also this is interesting because when you look at here from 0 to 16, seems like there is a correlation, meaning like one variable increase, another variable increase. However, after 16 years, seems like the trend kind of like stay or even like decrease. And from this 20 to 24, all the sudden it jump. So there's a huge gap between the like after 20 years or less than 20 years. And then another thing I noticed here is after 20 years, there's not much sort of like a correlation. It's almost like a flat. It's almost like the same. It doesn't matter like if you're more than 30 years or more than 20 years. It's simply the same. So what we saw the correlation with the scatter plot, we saw like 0.7 or 0.6, whatever the number would be. It might be because of the correlation relationship here, and also from this area to a higher number. So because it's jump. So this is why it's important to use different charts or different by using different technique to understand the relationship between total working and the monthly income. Because like I said, when you find the correlation, that's a very strong insight. However, if you make misunderstanding of the correlation, then you might lead to the wrong conclusion. So now Boxplot and scatterplot go hands in hand, and so it's very just one click to change. So like I highly recommend you try both of them to see more like kind of digging in the detail of the relationship. Okay, and then after that, there is we've been looking at a numerical, categorical, numerical, but also there can be the relationship between the categorical and the categorical. And I'm so sample question is, we have only 4 minutes now, so like I'm gonna kind of go skip through it. So how is a job role associated with education, or how is job role associated with attrition? These two, job role education, job role attrition, those are categorical. So how they are associated. Well, that's where like you want to use the bar chart, and then because it's categorical. And in this case, what we try to do is try to show the percentage of the roles, in this case, percentage of the employee. Then when you see the patterns or not. In this case, for example, x-axis is a job, I think this is a education role, and the color is a job role. And you see some kind of weird pattern between in human resource and marketing at x-axis. These two bars are different from other bars because of the different types of job roles there. Then you can start thinking like, okay, maybe like education is different, then job role is different. Same thing, job role and attrition. There's an attrition column, which means if this employee have quit or not. And then when you look at in the same way, it's like using that like 100% bar. And you can actually do the 100% bar by using y-axis window calculation. There's a menu called percent of total, and use that. And then like you can see, for example, this is a blue color represent the people who have left the company. So it looks like certain jobs, certain job roles have higher attrition rates than the others. So that means these two are associated or have some sort of relationship between them. And that's actually a good thing, good insights, because you can even dig more. And then one last thing is that like when you have, for example, numerical, like I said, can be categorical by binning or by categorizing it. So that means even that, I'm going to skip it here, even that this one is a job roles x-axis. Why the color is a monthly income? It's a numerical. But when you could make that to the categorical, making like a 5 groups with equal width or equal range, then all of a sudden it's like a bar chart, and this like a ratio bar chart gives you certain insights. For example, manager and the research director seems to have like a darker blue, which means a higher income. So like a more, most of the people in these two job roles have higher incomes compared to others, and so on. Okay, so those are the basically the set of the charts you can use to visualize variance and the association and correlation. And then one thing I wanted to emphasize is bar chart. Seems like sometimes we get fantasized by using new type of charts like density plot or scatter plot, but the bar chart or is simple. Like everybody knows a bar chart, but a bar chart sometimes gives you rich information. All depends like what columns you assign and how. So I highly recommend use that as well. Okay. And then the next seminar is part 4. That's it for the part 3, by the way. And the next seminar is part 4, visualizing uncertainty. I'm going to introduce error bar. That's a different chart type. But we are scheduled in sometime June, like early June. And then like after that, part 5 is a data wrangling stuff. Okay. So with that, I'm going to stop here and open up for the Q&A.